Modern cinema turned the mosasaur into a 100-ton, 70-foot crocodilian monster capable of dragging dinosaurs into the depths. But finding the animal's actual history requires looking past the CGI and the movie monster tropes. This diagram shows the true scale of the largest species. They maxed out at about 58 feet and 12 tons, with a sleek, elongated mass that operated under the strict constraints of hydrodynamics. They were not dinosaurs, but members of the squamate order. They were heavily modified marine monitor lizards, direct relatives of the terrestrial reptiles we see today. This raises a massive evolutionary question. 82 million years ago, how did a lineage of land-dwelling reptiles plunge into a highly competitive ocean and rapidly conquer the apex predator niche across the entire globe? Their success was a product of aggressive biological engineering, a series of adaptations that retooled a land-based body for total aquatic control. The first major adaptation was a complete overhaul of how they moved. Earlier ancestors utilized a snake-like, undulating motion, but advanced mosasaurs adopted a stiff body plan and a powerful tail fluke. This rigid swimming style, known as carangiform locomotion, kept their torso straight to reduce drag. Combined with a shark-like crescent tail, they generated the massive propulsion needed for efficient open water travel. They also transitioned from cold-blooded beginnings to endothermy. Unlike modern sea turtles, mosasaurs could maintain a constant internal body temperature independent of the surrounding water. This high metabolic rate provided the stamina to forage across larger areas and pursue prey into the cold subpolar waters that would paralyze most other reptiles. To remain in these deep waters permanently, they evolved to give birth to fully formed live young in the open ocean, removing the need to return to vulnerable beaches to lay eggs. The transition to tail flukes, to warm blood, and live birth removed the remaining biological ties to the shore. The lineage was now fully committed to a pelagic life. Adapting to the deep meant trading certain senses for others. They possessed a weak sense of smell, but compensated with massive eye sockets. These provided the exceptional two-dimensional vision needed to patrol near-surface waters. Their hunting tactic relied on that upward visibility. They were patient ambush predators, lurking in the darker depths and thrusting upward at high speeds to strike animals as they came to the surface for air. Their anatomy ensured a successful strike. They possessed a flexible skull and loose jaw attachments, including double-hinged lower jaws that could swing forward and backward to swallow massive objects whole. This diagram shows their most specialized weapon, pterygoid teeth. Located on the roof of the mouth, these secondary teeth acted as a mechanical ratchet, pulling slippery prey backward into the throat like a conveyor belt. Once a squid or a smaller marine reptile was caught in this grip, the ratchet mechanism locked them in place, making escape mechanically impossible. The largest species, Mosasaurus hoffmannii, used this lethal anatomy to consume giant sea turtles, large sharks, and even other mosasaurs, utilizing immense bite force to process large prey items. The fossil record confirms their aggressive nature. Skulls frequently show deep puncture wounds and broken bones, suggesting that rival mosasaurs engaged in violent combat, grappling each other by the snout to settle territorial or social disputes. This chart shows how multiple predators coexisted. Through niche partitioning, different species targeted distinct resources to avoid competition. While competitors evolved blunt teeth to crush ammonites, mosasaurs retained sharp teeth, specializing in large, soft prey at the top of the food chain. By partitioning the food web and specializing their anatomy, they secured their position at the top of the Cretaceous marine hierarchy. 66 million years ago, the KPG asteroid impact brought this evolutionary peak to a sudden end, plunging the planet into darkness. This dark band of sediment marks the physical boundary of the extinction event, where the global rule of mosasaurs was cut off. Paleontologists find their final remains in the lighter rock just below this line. Once crossed, the genus disappears entirely. The impact's fallout killed off the marine phytoplankton, triggering a bottom-up starvation cascade that deleted the foundational food source of the entire ocean. The asteroid's fallout weaponized the mosasaur's greatest strengths against it. A high metabolism and extreme specialization required a constant, massive energy supply, a resource that vanished as the food chain collapsed.